should be, yeah, so that
Yeah.
should work.
Yeah.
All right, I'll head out. This is the camera feed right now, so it's capturing
Okay.
that. Do you want to keep this? Or should
Yeah,
I
yeah,
keep it?
I know how to
You'll keep-
change it.
Perfect. All right.
Many thanks. Yeah, you too.
We're under a blizzard warning. We may have no class tomorrow.
Probably the connection will be still active, and I'll try to.
Remote, we can do our.
If you are not allowed to come into class, I will
Yeah,
just
yeah, yeah.
make it from home.
Okay.
And maybe listen it from
We
home.
could be covered up and watching.
Yeah. Yeah. So, and probably we'll finish earlier today. So if you need to refresh yourself, there is a can with coffee on the back. Just take. So let me set up the goals, and we will pursue them together. So I will need maybe a couple of minutes to refresh it for myself and then to deliver it for you. Let's do the simple thing that Mary was asking about on the last slide from the yesterday lecture. So just Jim, thank you for coming. It will be not new for you. You already did it in the past. So let's make tetrahedrally coordinated titanium hydroxide, and just look for like simplest electronic structure method, particle fork, total energy, affinity, and electronic ionization. And I'll go through like suggestions how to achieve it. So this is the neutral molecule with no zero total charge. It's not neither anion nor cation. The benefit why we selected because it is as small as typical chemical molecules, but it has some inorganic flavor because it has transition metal. And I will do it myself. I'll go through instruction. So try to first use it particle forks with 1 or 2 DZ basis set, if you are aware what I'm talking about. If not, I'll go through it. And ideally, we should prepare all input files on Photon, and then upload it to CCast and run it there. So if something will not work, it's not a problem to run this small molecule on Photon, but we should slowly depart from it and do things on CCast. So if it is clear what to do, just try to. If not, just wait for me. Optimize total energy, electron ionization energy, and electron affinity. And then we will compete who will get smaller or higher value. So if some people restore wipe off the memory every night. So if you are like this, I'm just recalling, find mobile extern, download it, and run. And from there, we will walk into the Photon server with GUI editor to prepare new files, and then from there we will walk into more powerful facility. Right? So I think as soon as you reach this goal, it will be enough for today. Yes, I'll give instruction about accounts if you want to, and just wait a little. I do not want you guys to go too much ahead of me. I want to.
I'm just saying for logging in purposes.
I'll write it.
Okay, well, I'll wait. I thought. Okay.
And the
I'll chill.
system administrator who visited your presentations a week ago did set up a general account for everyone in the class, where he told that he will be erasing everything after end of semester anyway, so you can store anything there. Who was presenting on MobiX term? Okay.
This guy. Do you need help?
Maybe. If it doesn't work, I will ask for the help.
Okay. It looks like it's paused if you look at the Chrome symbol like halfway. So I don't, maybe pause it and unpause it. See what happens.
No, it looks like
Okay.
maybe I need to reload it. Or do a second copy. Or maybe the system that makes recording slows down all other operations.
Question.
Yes?
If he deletes it, will we still have access to the first option you presented us?
What do you mean?
Your,
Hey, Kevin.
are we being recorded right now?
Yes.
Okay. The first option you showed us originally.
Yeah. Feel
Okay, good, okay.
Feel free.
He's just starting. He's having some computer issues, but as long as you try to get to hear him, you'll be right on pace. But the recording is just, once he gets this set up, he's ready to.
Yeah, thanks for being careful to this option. I'll put it off record when something needs to be communicated. Yeah, it looks delayed. Maybe wires are frozen.
Maybe. That's why we need fiber optics.
So let me bring up this public account, but if you prefer the other one, I don't mind as well. And let me know if you are not happy with it and you need another one.
Professor, what's the password for what you wrote on the board?
Oh, yes. Just a second. I will write it on the board as well. Let me refocus that it will be not recorded. So if you elect to use this one, I have transferred there all the directories. And it is what Kurt was teaching us to do a week ago, right? So our sync and then source directory and target place.
So we can still use the old one if we want to? Okay.
And here, if you have forgotten how to launch the GUI interface.
You put in the same thing.
Oh, it's easy.
What masking did you?
Yeah. Yeah, I tried both of them.
Permission 9. Is that a G or a 9?
Logically, it should be 9, based on the year today.
Did everyone notice the underscore between chem and the number?
Yep.
Because that was my issue.
Mine.
Well, no, in the username.
Oh, yeah, yeah.
And when you will be there and you start drawing, note that for periodic table, for each element, there are several coordinations, right? And if we do want to have 4 tails, it's reasonable to start with 4 dangling bones right away. So if you select something else, it will create difficulties in in coordination later on.
All right. So did you use the password?
I just counted.
All right. Capital C. Nine.
Okay, try that again, but try lowercase.
I did that. Okay, question. Is that capital Chem on SSH capital?
Okay, just copy mine.
I'm doing that.
Yeah, and notice that NES used capital too. The NES used capital.
Okay, Chem.
I certainly don't need 168 hours for this job.
No, I don't. It should be done in a few seconds. So later on, we will be talking more on the parameters,
Say no.
on parameters for the for setting up the calculation, and at a very basic level, you need what? Whoever already exposed to here. Before, when we were practicing simplest optimization, everyone was encouraged to do force field, right? Molecular mechanics. So here in this menu of the method, the molecular mechanics is least useful and quickest, and it doesn't give any electronic structure. So right now we are going a little ahead of class material, but to push the button we do not need class material, right? So the semi-empirical are good, and they are really well implemented in HyperCam, yes. And HyperFoc is also useless for practical applications, but it is one of the theories that is rigorously derived. So many other theories have cheesy things in them, and this one is rigorous, although not for practical applications, not right. And select this one.
So then how does HyperFoc compare to DMT?
It always gives larger gap. So whatever is semiconductor will be seen as dielectric. It makes gap like 2-3 times bigger.
So it kind of overestimates.
Correct. Yes. And another very basic thing is so-called basis set. Anyone wants to quickly teach us what it is? I'll ask for your help. Well, let me play my favorite game and ask who is happy with the combination of words basis set?
Basis set?
Yeah. Who is completely uncomfortable?
Basis set.
Uh-huh. And who's in the middle? Heard something but not sure. Okay, so let me. I'll ask for your help. Let me check with Ben and Gage. What are their impression about it? No, Ben must know. It's not interesting to torture him.
Torture me.
Yes. So what's your impression about the combination of words basis set?
I remember them from class last semester, but I don't entirely remember how we were using them.
But how? Just your artistic impression of these words. Like basis means bricks set. Like you set the bricks and stand on them, or
Yeah, we're using this to build onto something else. Sort of.
but what are they? What is basis set?
I forgot.
Wait, do you mean basis set as far as mathematics go?
Yes, absolutely.
Okay,
yes.
then I know what it is.
So what it is?
Okay, so let's say you have a vector space. Vector space is simply a set of vectors. And then if you have a basis set for that vector space, that means any vector in that vector space can be written as a linear combination of those basis sets.
Super. Who's happy with this definition?
So are you saying is it's a place for vectors sit? Is what you're saying?
So have you heard of unit vectors x, y, and z? So that Cartesian vector x, y, and z, that's a vector space. So x hat, y hat, and z hat are basis sets because, as you know, any vector in that space can be written as a linear combination of those sets. Does that make sense?
Is that in part, you're saying a linear combination of those sets?
Yeah.
Because it's saying x plus y plus z, so that's a linear combination?
Yeah.
Okay, yep.
Good.
I get it.
And if you have mathematical functions, they can be represented as summation of some simple functions with constant coefficients. Right?
Wait, say it again?
Arbitrary function can be expressed as summation of simple functions with some coefficients. Like,
Yes.
like Taylor series is
Mhm.
example where polynomials are serve as a basis set.
Right.
Right? So I know that some of you may not feel comfortable. So Mary?
I want to add to what you just said. So it basically, not to overuse the word base, you're spanning the atoms and their orbitals within whatever you're defining here. So for example, if you use 631G star, the star indicates the orbital. You have two stars, but you're doing those lighter. Sorry.
No technical difficulties.
Okay,
Only
okay.
major
So
concepts.
it's basically you're defining the atoms that you're going to be using in your set, and the mathematical representation of those atoms in the vector space. Would that work?
Good, good.
Okay.
Because you could represent atoms differently.
Not atoms, not atoms.
Elements.
Wait,
Oh, sorry.
wait. How comfortable, I know it is very hand-wavy and rigorous, but probably through free discussion things go much easier. How comfortable are you guys with atomic orbitals for like hydrogen?
I understand the concept.
Yes.
Yep. Everyone from who took freshman chemistry should be happy with them. SPD orbitals, right?
I can use a review on that.
Okay. And if you compose several atoms in a molecule, the orbitals are not atomic orbitals anymore. They are distributed and they take space between atoms,
Right.
right? But one can say that these orbitals in a molecule, you can call them molecular orbitals, they are adding together superposition of atomic orbitals,
Okay.
right? So they have so many s orbitals from one atom, so many p orbitals from other atom, add them together and get some ugly shape in space.
Oh, so SP and D orbitals are the basis sets?
Right.
Okay.
Right. Perfect. And SPD orbitals, they are mathematically bad. And there are some good mathematical approximations. You know, good and bad functions means with, without singularities, the ones that are easy to integrate and differentiate. And like s orbital has a spike at 0. It's bad mathematically. And Gaussian software is designed because they replaced s orbitals with Gaussian functions, basically. And there is a lot of work to create functions that do replace SPD orbitals with something more advanced. And select any of them and see the consequences. Nothing bad will happen, it will just change the precision. And if you have transition metal, just a blind guess is 1 or 2 GZ is like balance between precision and numerical expense. Yes?
So but the thing is, you can't use 631G on the titanium. You have to use L-A and L2DZ because it won't include it. The 631G is for the lighter atoms. Like so to how I understand it, the way to look at it is you want to make sure you use a basis set that spans what you're looking for. Like in the periodic table, like the lightweight atoms you can use for the ligands, you can use.
Yep. Generally, they arranged the lower in the table, the higher precision and the larger number of basis functions in the basis set.
Okay.
But if you go too far, it will be too expensive.
Okay, I see.
So, and after you select these two things, so I'm cheating and I do not want to do optimization, I immediately put energy. And energy is always quicker. It means do not move atoms, explore it only at one atomic position. And then nothing bad will happen if I will run it immediately on a photon, but I just want to probably play respect to other users and system administrator. So I click submit, but I will not run. I will just save the input file.
Can you go back to the method?
Yeah, let me save. Decline, overwrite it, yes, and decline submission to Gaussian. Cancel. Yes. So any other questions? By the way, in whatever 3-4 weeks, there will be presentations and someone will be presenting on this subject. So these two things are minimal to set up. And this shell, this GUI is kind of a little intellectual. So if you will have odd number of spins, it will play automatically, give you suggestions of church and multiplicity. And we will probably cover sometimes in class just a little refresher because sometimes it goes away from the memory, like what is multiplicity, right? So, good?
So maybe I'm a little confused on this. So But if why is it that Gaussian gives me an error if I were to use 631 G star or 631 on the titanium? Why would it be, like, it might not say it, like, it doesn't include that? You know what I'm saying? Like, it's not in that set? Why would it give me an error?
I'm not ready to answer, but
Okay.
generally, the transition metals explicitly include d orbitals, and basis set should include more orbitals than you are populating.
Okay.
Like if you have occupied d orbitals, your basis set should include like f and g orbitals.
I gotcha.
Right.
So we're going, as further down we're getting more population in terms of the, okay.
Yep. So if you look for simplest bases, they will work for like carbons, oxygens that do have only s and p
Got it.
orbitals. And by now, I should have the
Did you even make a molecule?
huh?
Did you even make a molecule? Did
You-
you make that molecule that you wanted?
Yes.
I just haven't seen.
Have you seen it?
No. Just wanted to make sure I was close to what I. Yeah. Okay. I'm good.
So I thought you were asking synthetically. It's metastable. It will not live long enough, but it does exist.
No. Yeah. I was talking on the side.
So and now let's practice curiosity and just look inside what is in this input file, because one day we may want to set up this files manually. So here are your favorite Cartesian coordinates, right? So you show the type of element and then Cartesian coordinates, right? Yes? Huh?
We made the titanium oxide.
You expected to do it? Let me circle around and make sure that everyone has it.
My log file is.
So we have to go to Gaussian and make that
Yep.
This one is not good because it has 6. And then right now those are like unspecified terms. Everyone, did you guys get the?
Seems good.
I'm good. He just
Let's optimize this right away.
What department are you in?
Physics. Chemistry, right?
You coded.
Yeah, I didn't know you had a polymers department.
I don't know. I don't really talk to anyone else about departments. I don't know. I assume no one knows.
Are you guys pretty tight knit?
And then like, who with each other or tight knit as?
I guess both.
Or where, you know where the John King building is? On campus.
No.
Yeah, so we're corner of campus.
So you're isolated.
Yeah.
Is there anyone in class who was or is teaching, serving as freshman chemistry T1
In the past.
in the past. So, as a, I never took freshman chemistry.
Aren't you lucky?
No, okay, so here are your students. Can you tell us something about PSPER, something like why then bonds why lone electron pairs want to repel from each other?
The lone electron pairs have more.
Just tell something more.
They like being more isolated than bonded atoms. So if you have titanium, whatever, titanium hydroxide, so you're going to have titanium.
Just few words are fine.
building?
So you're going to have it as plane, which I apparently did very carefully, but you're going to have two lone pairs there. So it's got actually 4 electrons groups around it, 2 of them being lone pairs, so it's final geometry.
Okay.
And again, I type the password.
And what else? For simple thing, all this things are short.
I'm looking up Dimitri right now, so I started looking at the so he told me that after 3 or 4 months, after I do the second 2 presentations, then I can start moving these switch.
The first one?
Second one.
It's always a small school. I think it's my first second semester here. But it's the first year.
So you guys got the
grad students, so even though
I was
What's your advice?
telling you things about so not just our
where the computation portion from.
Did you take freshman chemistry? No? Okay, David,
Yeah.
we need you instructions.
You guys do a lot of-
So can you please extend anyone who also took some basic level of inorganic chemistry? The freshman chemistry should be sufficient. What
Which
is
I assume is me again.
Okay, what is the difference between square planar and tetrahedral?
Square planar, all the atoms are in a plane. Tetrahedral, they make pyramid type shape.
Okay, but what is the implications to electronic structure, to splitting of d orbitals?
Oh, they in d orbitals in square planar they split in a 1 to 2 to 2 manner. In tetrahedral they split in 2 to 3 manner. So
Yeah, if you draw something on the blackboard, it will be okay. And then I can retire, and David will teach instead of me.
we have a marker.
We should.
Here's my permanent.
Focus, focus. Yeah, maybe there. And I'll
Yeah, so it's like a physics way.
so here's your hour of glory. You are on the focus of camera.
So we got our 5d orbitals. In tetrahedral,
Is this in your second year?
they split into a T and an E pair orbitals.
Okay.
And then in square planar, I want to draw an octahedral one, and I don't have octahedral here.
Uh-huh.
But they end up in a,
You can erase this second part of the, like, we're optim. Yeah. And we are doing things over slow, too slow. Everything that we do can be done in 5 minutes. So it's just because of learning. Ah, great. So, 1, 2.
so then this is the square planar. This is an octahedral. This is a tetrahedral.
Can you draw square planar and tetrahedral just schematically? And not carbon, because we are
Oh.
talking about d orbitals.
Okay, then.
So we are doing things in a really intelligent and intellectual way. We are thinking more than we should. Okay, yeah, thank you. That's perfect. I don't have more smart questions.
Wait, so
It
this
was-
is
it was
literally
right.
how
I know,
atoms look on
I
the
don't like
molecular
it.
scale?
Yes.
Okay.
Yes.
Why?
On level 1, yeah, square planar. And now, last question. What are these little dashes? Oh, let's ask who knows what are these little dashes? You do? Who doesn't know what are these little dashes? Okay, then David, please teach us what are these little dashes.
So these represent orbitals. Specifically here, they represent atomic orbitals. These ones represent molecular orbitals.
And what is y-axis?
Y-axis is energy.
Make sense? Or more instruction is needed?
What's a molecular orbital?
Oh, it's not molecular.
What did you-
Oh, molecular is combined when you build a
Well,
molecule.
yeah, molecule, yeah. But you said two orbitals are two different things.
So,
You said two different-
yeah, I'm good. I think I can explain the rest. You did the hard part. So, with these calculations, we will be able to find the energies of electronic states, right? And the interaction between atoms in the molecule affect how deep or how high are the energies of orbitals, which can be occupied or unoccupied by electrons.
Yeah, how they, like you said, how they interact, yep.
So if you remember hydrogen atom, how many d orbitals are there? Huh? Not occupied, not how many d electrons, how many d orbitals?
The normal amount.
Huh?
The normal amount.
Yeah, what's the normal amount, or how do you count? How do you, like, how many s orbitals? Well, one for like first principal quantum number. For each principal quantum number, there is one s orbital, and for principal quantum number 1 and 2, there are no d orbitals. Like, starting from principal quantum number equals 3, there appear d orbitals. How many d orbitals? 5. Why?
12 plus 1.
Yeah, 12 plus 1. Good. So you're fine with this concept. And what is the energy of each of the d orbitals in the hydrogen atom? I'm not asking for the number. Do they differ from each other, or are they the same? The same, right? But if you take and if you take any single ion, any hydrogen-like atom, energies of d orbitals will be the same, right? But if you take a metal that has d electrons, filled d orbitals, and you attach some other stuff, like I'll
And the
put.
case I drew was literally just, I just do hydrogen for everything. But
That's fine.
whatever.
That's fine. With oxygen, it is a little more realistic. Then, so there is 1, 2, 3, 4, 5, and they all have the same energy, right? But due to interaction, due to electrostatic field exposed by this additional parts of the molecule, and chemists like the word ligands, the energies of orbital splits. Some of them get higher energy, some of them get lower energy. And depending on the spatial arrangement of these ligands, one can get very different pattern of these d orbitals, of their energies. Right? And specific, highly symmetric arrangements are typically more stable. So when we are doing this titanium hydroxide, this tetrahedral, when they are in the pyramid shape, are more preferred You may do like a brave experiment and put them in square planar,
I
but
just did.
it will be not.
And it didn't terminate.
Try this one first. This long discussion was just because I saw something in.
So really,
Nate.
it's a good experiment. This one failed on the right, so then try the left.
So now.
So.
That's the titanium.
Okay. Now next is what?
I did not do that at University of Maryland College Park. Yep, I came here. Into the bitter cold state of North Dakota.
Don't forget snowing.
Oh yeah, it's pretty snowy too, especially today.
Well, we're gonna have class tomorrow.
Not Adam, not Adam,
What?
but,
We're under a blizzard warning. Like, and we're supposed to get a foot.
Yeah, yeah.
Wow.
Oh, what is your titanium?
Yeah, University
We'll
of
probably do this class via telecom tomorrow.
Hydro and
Or
then
television or
hydro.
whatever.
Once.
Cool. It's in
We'll
College
change
Park.
from titanium tetrahydro to oxygen.
Oh, sorry. Okay, so there's.
Maybe it's hidden.
You're closer to DC.
Yep.
You're closer to DC than most.
Yeah, I literally live right next to DC.
Well, I was visiting for one night only. And then I drove back to Minnesota. We flew there, picked up a car, and then drove back. So the very next
So there
morning,
should be
10 a.m.
another window over
It probably took you like 18 hours, I guess, right?
Yeah.
So did you like drive like 10 hours and then rest or?
I was with a friend, and he bought the car, so he drove home because it was like his car. And we were on a good flow. Just drove probably 8 every 5 hours. It was really lucky. I don't know, we both took it.
Yes.
Driving.
Cool.
So did you try to go there or?
Is it because of the one is two?
Wait, it means Maryland or here?
Yeah, well, my
Yes,
number
because,
was
there was one test who do orbitals, 3 p orbitals.
Have you heard of the APS grade program? So I applied
Probably the
to
best-
through there.
Let's
It's
make
like a
competition
program
good,
that
explain it better.
that gives out your application to a lot of graduate
Nate,
schools and then. they'll
why is there a
decide
5D
if they
orbitals?
want you or not.
No,
So,
apply there once.
So,
Why not 6, not 4?
because
what did you do your undergrad?
when you're at like n equals 1, like the ground state energy, you're restricted to having only.
I'll ask you after.
Zero for the next quantum number. But if you go to n equals 2, you can have either 0 for L or 1. And for each value of L, there's
I can
like
draw the five.
there's the
Oh.
0, 9.
quantum number. Remember that? Like n
No, not enough. Now let's bend try. Why there are 5D orbitals instead of like 4?
Good question.
Okay.
I want to know the answer as well.
Okay, Gage?
I don't know.
You should. You did presentation on related subject. Like you were doing Zeeman splitting.
I don't know.
So what's the difference in this 5 orbitals? No. If it is an isolated atom, energies are the same. But there is something different. We all know from kindergarten that they have shapes like petals, like flowers.
There's localization, geolocalization. The way they load.
What is different? What Bohr's model tell what is different in atomic orbitals? If Bohr models would be correct, was it spin? Spin is a property of isolated electron, but if it is electron orbiting around,
I don't remember.
You should. Like, orbiting, how quick? Speed in the orbit? Or in, like, orbiting maybe with the same speed, but at slightly in different planes. So angular momentum, or projection of angular momentum. Z projection of angular momentum. And these d orbitals would respond differently to magnetic field. Yeah. Good?
Which is positive L and negative L?
Well, M goes from -2, -1, 0, +1, +2.
Alright.
Magnetic quantum number. Does it click anything?
Kind of brings back my
Okay. So if there is no external magnetic field, they all have the same energy, but they I'm very vaguely profiting. They kind of orbiting with different velocity in different directions. And before applying magnetic field, it's all the same for total energy. Right? And just due to principle of quantization, due to the fact that one wants to have even number of standing waves, there are solutions with like only one hump standing wave, then there are which is s orbital, and then the next solution is p.
Yeah.
Next is d, and they differ by number of the like humps and 0 points in this spherical standing waves. So just from the symmetry. So this number of 5 d orbitals is can be found exactly. We do, in this class, everything will be done by computer for us. We do not need to know much, but just general idea.
Unless you're presenting me,
Okay. Unless someone tortures you with hard questions. So everyone is happy about this, right? And everyone has the titanium hydroxide, right?
Are we running it?
So what do we have here? There are Cartesian projections, which would represent the molecule. There are these two numbers which stand for what? What are these two, 0 and 1?
Charge and mass density.
Well, okay, thank you. And what do they mean?
Charge and multiplicity.
What is charge and what is like? In one titanium, 4 oxygens and 4 hydrogens, charge is not 0. They have some electrons. What does it mean, charge 0?
It means the net charge of the molecule.
So total positive charge of ions is equal to number of electrons. They compensate each other.
Yes.
So if we add or remove electron, this number will needs to be changed from 0 to plus or minus 1. And what is multiplicity? If the yes,
It's where, so you have, you can have 1, triple, like 3. It has to do with the unpaired electrons in your system. So you have to be careful about if it's truly 1 or 3, or it could be multiple, especially if you're dealing with ions that have more than 2. Like if they're 2 plus charge.
But if the all electrons are paired, highly likely that it will be a singlet. Multiplicity will be 1, right? So it's for stable organics. One can live a long and happy life with dealing only with singlets.
Yeah.
If the deviation of this number from 1 is needed when you deal with active radical or transition metals or like ionized species. And where does Hartree-Fock and like method and basis set are entering? Look, first line something like check file, and second line after this number symbol, you have HF divided by ln to dz. So later on, we may be lazy to run this expensive GUI because, like, if connection is slow, you do not need it. and you can just modify the second line of the code and make wonders, right? So I'm going to upload and run, and then we'll attract your attention.
Is anyone running their job in CCAS with PBS scripts? You get a tip. Are you? Make sure, are you using Linda workers? Are you using Linda workers? Okay, because you have to, it's very case sensitive, so if you don't have it just right, your job will not terminate, and I run into that all the time. I forget to change that, so.
Wait, everything is okay?
It is running, hopefully it terminates.
I get it.
Here.
Do we get an error like as soon as we send it?
Let me help them. Are you doing CCAS?
Well, that's the question. Do we do it this way or do we do it?
Are we doing it in CCAS or in the?
CCAS is better.
CCAS is better.
So do I don't need to do anything?
Yeah, you do. Okay, so. Go into job type, just to make sure.
You get feels more following.
Okay, so job type. Yeah, you did. Method. Everything is good. Why is it something else? What do you have here? What is that? Why is that?
That's, you know,
Something ain't right there.
so it's like,
Titanium is
oh, I went to Thal.
you got Valiant, you have the wrong thing. You need titanium. Titanium is gonna be right here. And you want, go back to your thing. You went a little too fast, you're gonna want.
I think I have it, I just need to. click
Yeah,
it.
yeah. There you go. Perfect.
Alright, so let's try it.
There you go. Here. So now it's the title. Just put test job for titanium OH4.
Yeah.
TiOH4. Go to link. You want to hit down here,
Sure. Point.
hit the default. Specify. Specify. change the MW to put 10 where 6 is. Go to MW, goes down, go to PGB. Check for what, need specify? No, specify. Leave that, miss the rewrite, go to lane workers. Hit specify. Leave that blank.
Delete it.
Go blank, go to share processors, specify, leave it at 1. That's fine. Go to general. Ignore symmetry. I'm right here. And you're done. It's good. And it's made. And then you already had it, so hit save. And then hit yes. And then hit cancel. And you want to change, you want to take everything to
So can I exit out of my?
yes, because your file's in your folder.
Yeah, my file's in the CCAS.
You'll have to make a PBS script in CCAS and everything. Or PBS file.
Right now, I'm gonna CCAS. So, do you understand what like this?
You're still kind of in.
This is not me saying means, you know, because I took.
I'm getting weird dihedral errors, and I don't know why.
I mean, this is more like server. It's basically like a Linux, like lookalike system.
Do it,
That's what everything.
So,
I have a question for you when you
I will be very soon with
I
you.
don't know how to do that. So,
Like that? Okay, so, type like nano.
well, are we, you said we need to do a PBS script, but what, I need to change my file to .pbs and then you can't actually.
You've run PBS before, right? Okay.
I can ask someone else.
Let me.
Quite a bit.
You don't have any PBS script on you?
No.
Okay.
Are you guys doing good?
This guy is just making compounds.
That's okay. We're learning.
This is making stable compounds.
With PDB.
And that's what this Dimitri's bringing up is the.
To bring to PBS. Yes, sir. Okay. I don't remember ever being this full. All of the same, which is usually the more important.
Alright, while he's doing that, I'm going to show you guys a tip. Do you have the markers? Awesome, thank you.
After February,
Okay, just to give you guys a pro tip.
So,
Linda workers, the L and the W needs to be capitalized. It just doesn't like it when it's lowercase. And this will just be left blank, so I'm giving you a heads up.
So if you're
so Maryland, I feel like it's relatively true snow.
That's definitely one of them.
it's like this, right?
Yeah, the lowest you can go is like 30
So it's snowing and snow.
Well, yeah. Just
in Maryland, like with my parents. And then from like 12 years old to like when I was like 21 or 23, I lived in Maryland. Then I moved back to Maryland, got my degrees, and now I'm here.
What did you do in Illinois? Just hang out?
I went to high school there and got my associate's degree.
I have an associate's general associate in arts and I think that's my associate.
Yeah, I got 2 associates, one in drafting and another in like math.
Yeah, I stay with pretty much around the Midwest. I went to Indiana for a year to work.
So you go straight to college after you graduated?
Yeah, my parents kind of pushed it. National progression.
So then you got your bachelor's right out?
And I went to the 2-year school and then transferred to a 4 years. And that took me 3.5 years. To get my 4 year degree. And then I worked and took me 6 years to get a 4-year degree. And now I'm back. I fucked around the first year. I suppose you took a break from high school to school?
A little bit,
Yeah, I totally went. My parents really pushed it to never take a break from school because they say you'll never go back. But they took 1 year off.
Did you take a break?
No, but in my first year I did really bad. It was super
If
cheap.
you don't mind me asking, what did your parents say about it?
Well, I hated it. I was living with them, I couldn't see it. Because my idea was, go to school for go to school, we'll be willing to let me get with that. I was close enough to my hometown. Hated it, but I was like that. And then after that, first year, I just left it.
Alright.
So there was my, never thinking about fixing it.
My parents were sick, we couldn't take care of them. They're better. So, what's their degree for fun?
I was thinking, I don't have any kids, and no family members, I have enough space to do. Just like the time you go work for them all, and now, and they go home.
I went to some old Broadway and like Bismarck. The old ways look really packed. It's like a one part.
Yeah, actually, we all Mary's and we three of us go to Old Broadway. Most of them. Some of the girlfriends and one was married. All we know is what to do.
Okay, let's go through simple way first, and then I'll go over the longer way. Those who already ran things in Stochastic with PPS may just relax and do whatever you did before. So what we are doing right now is not for industrial repetition again and again. We will do better way, but try to go into your directory where you save your input file, type the name for the executable, then space, and then the input file, and just hit enter. You already have some answer.
So do you want to check log or? Cause you see.
Wait.
So all you're doing is, that Geo9 is setting,
Mhm,
is
mhm.
submitting for you?
Yep.
And then it knows that you're just optimizing?
Mhm.
That's all we want?
Yep.
Is that because of the?
Sure.
The Geo9 is it glaring optimization or is it?
No, it's
or is it
it's
something?
as soon as it was under production, I would just
You get it?
Well, I was
Put it 0 now. Put 0 instead of an O.
Yeah, but I don't. I'll wait.
Oh, it's me. That you. You would go.
Well, if you want to start.
Yeah. You look at it, which is, but then a lot, just regular bubble shooting.
So this is a lot more sophisticated than like you have.
I wouldn't say that. Have you played bubble shooter?
Isn't this the same thing?
It's the same thing, but there's no spinning, it's just like bubbles in a bottle.
I think I have something like that on my cell phone. Like this?
Yeah, it's the same.
Okay, so I played both bubble shooter and bubble spinner.
I know you were trying to, that was just like a quick-witted comment, if you meant it to be, it's like, if you told me, that was good.
No, I do not, like, I thought you meant that bubble spinner was more sophisticated.
It is, but the way you worded it, it's like, oh, it was funny, signal.
Right.
Just in my directory, I'm still at CHEM676. Yeah, this is CHEM676. I would go in. They said it was somewhere.
place.
I see Maryland, you know, just because it's the first one that was in area. The result, you go to generators here. And the problems are relatively isolated.
So after you do this thing, you should have the file that ends with the .log, and right now we are doing not the smartest thing in the world. We will be doing smarter things later. Right now we are just running it on a photon on the small cluster, but not through the mouse operated command, but through command line, right? So when you were playing with Gauss U, there was an opportunity to click submit it to the Gaussian, right? And most of you have already practiced it. Instead, one can go into the command line and launch it by giving the path and name of the executable and then the input file. And since we intentionally selected very simple task, it is expected to complete really quick. Then, yes?
G09, is that telling it to optimize, or is it just submitting it and somehow the information we provided previously tells it it will optimize?
Does the question from me has sense to everyone? Anyone, please lift hands if you know the answer. One? Okay, one. So the question was, does the name of the executable tells that our task is to optimize or to find energy? Or the task is encoded in the input file? Who is for the executable? One. Who is for the input file? Majority. So you know the answer. Majority is always correct. Main principle of democracy. So when we look into this .com file, once again, if it doesn't show anything here, it means just to find energy. But if it will be something more advanced to optimize or find normal modes or orbitals, it will be additional keywords here. But content of the input file determines what to do. The executable is a generic command which is relatively smart, and it will read content of the input file and read what we want to do. Make sense? Good. Right now, the output file was really, really short. 1, 2, 3, 4, 5, 6, like 10 screens. But as further we will go through the course, the longer this output files will become.
What do you type to get the output file again?
ls minus lt shows you last file that has been created. Right? And you just look inside. Yes?
I'm having problems with this file. This is the error I keep getting. And I originally had changed it to say opt equals Cartesian because I was getting some dihedral errors. So I'm trying to figure out what is going on.
Just borrow this one. So try to look inside this file and explore how it looks like. Or since the file can be too long, instead of more, you can tell less or better tail. So tail means looks at the end of the file, and the last line should include normal termination. If you have normal termination, it means everything went well. Huh? Please raise hands who has normal termination. 1, 2, 3, 4. Who has something different than normal termination? 1, 2, 3, 4, equal. Okay, I'll go around and make sure that everyone has normal termination, and then we'll continue the discussion.
You just keep pressing.
Yeah.
Is anyone actually optimizing the structure or just doing energy?
I'm sorry.
Energy? Just energy?
No, it's usually you can just.
So now what the safety does.
This one?
I don't know why there's no button. They were there earlier.
Okay, I'm doing energy calculations. Is anyone doing optimization? No? Okay. Because it won't work. It's not
I'm
working.
supposed to double it.
You want the safety?
It's only displaying the first part of it, right? There's nothing up on the top. So keep that.
Okay. So keep that.
Hold on to your hand.
Okay.
Then now you're on the bottom.
Oops.
You're done, you're done.
Yeah, see, now it did it. Got it. I got finally a normal termination. I was trying to do an optimization, it just wouldn't work. But I did the energy and it did fine. That's just not gonna help me. Because you're not gonna be doing energy calculations. This is just to see how it works. We're gonna be doing optimization, which is much more complex. We're just doing energy, yeah. I was trying to do an optimization and it was being a flood. Just energy. Yeah, it took like a second. I got normal termination. It's actually kind of nice to see that because I've been seeing error termination for weeks. So now it's nice to see the normal termination. Okay, maybe weeks is an overstretch. Maybe a week.
I was just showing you how much it's showing you 50% actual data. Yeah, tell me too. I understand your life.
Okay, so I have normal termination.
God, I've got so many questions right now.
I don't know about this.
February 6, 2018.
I think I saw an notification on yours. So, that would, but all this information is used for images. And I've never used Gapsy before, so I'm not 100% sure what it is.
What's wrong?
Jeez. I always wonder what this is router.
Which side is?
Well, in the block file. Like all of this stuff.
It gives you, these are datas that you can use at some point. So Mulligan, I forget what that is. SCF is, it's been a while. All these things mean something. So you can grab this stuff using ProScripts and plot data and make pretty pictures.
Yes. Can you see?
Yeah, sure.
Yeah. You?
It's fine.
Do you ever, or did you see that?
They just keep adding. Yeah, I think I got like 2 to 3, but I never got it past like 4 or 5 or 6.
You said it was
Like adding bulbs like 5 or 6 times.
Oh, you get any edge. Oh, nice. It would only be at the top.
So do you play video games?
I love myself one game. I do Daytona.
Is that like an action adventure?
It's like League of Legends.
What is the computer and
It's an MMORPG. It's a massive online multiplayer game.
That's the only game I've done myself.
Alright.
Yeah, it's just something.
I just like computer games like these. I don't like buying video games or like I don't buy video games. I just play computer games like these or I like download free ones.
I know it's free, but you need to do it.
Alright.
So you don't use Steam?
No.
Yeah, so you know, kind of weird, like download Steam. There's always games you can buy on there here for free. You just download them. So it's kind of like at your console. You just play those games on your computer. So,
What kind of computer do you need for that?
I mean, I don't have credit with the stuff where I just send them a game. Somewhere certain. That's a speed a lot of whatever. Need a better computer because and then there's some games that are pretty like a 2D
Yeah.
Does anyone has abnormal termination here?
All free, but you just need to download it. And like download for games. So I don't free.
No, no. So what's the question? Oh,
And I got it. I'm with the
Okay.
energy here.
It's good. So, congratulations on the first job that you submitted, not through the mouse operated thing, but through the command line. Either today or next time, our next task is to run it through distributed computing. But maybe not to waste time, we'll go just to little analysis. before we go through the content of this log file, let's do file open Gauss view and look through the resulting calculations through the Gauss view. I know that we could do everything in the integrated way, but we slowly need to depart from it because we will need to do things do larger systems. So you will not see your output file unless you change type of the extension, right? So change it to the log, and then you will see your output file. So it will pop up the geometry, which will be not changing if you were not modifying it. And then there will be button results and summary. Right? So the main result, which is here, is this total energy. So this many minus 360 atomic units. How small, how large is it? What? Well, it is very negative, but by amplitude it's very high, right? What is atomic unit of energy? How many electron volts?
27.2.
Right? Ben and H should be aware of it. About 27 electron volts.
Sounds familiar.
Good. So the total energy of this molecule is minus 300 times 27, which will be huge, right? Which means it is stable. But the absolute value of total energy is not very interesting, right? There are more important things. So let's get acquainted with the output file. So the thing we may want to focus is so if you want to find total energy, you should look for this part, SCF done. And if you want to parse a line from a text file, you can do grep, then your keyword like done, and then name of the file. Let me repeat it. So by this command, you can extract total energy out of your calculations. Anas? So it is answer to your question. Yes?
I want to make this a basic question, not get too detailed. But it says after 17 cycles. What if you have 68 cycles? Is that maybe it took a little longer? Does that mean something in particular?
Remember the homework that you haven't started to do.
Oh, yes.
The examples that we were doing and where I did like 3 mistakes by the blackboard. So while doing optimization, it goes through cycles.
Mm-hmm.
When we are looking for electronic energy, there is another algorithm that also goes through cycles. And there are some randomness in the initial conditions where you start. And then it goes until convergence is achieved. So exact number of cycles is not an observable.
Okay.
Okay? Make sense? So if you need to find total energy, just practice this command. Correct? So when you do have access to Gauss view, you may just open your log file and look for total energy. But who knows if photon access will be closed, and you still will have you run Gaussian on other machines, and these text files are much easier to analyze without any graphical connections. Right? This is like if you were relaxing and sleeping, wake up and remember this. This is something that we all will need to do. Now, let's look through the output file once again. So please try to navigate to this portion. So let's play my favorite game. So who feels comfortable with the words alpha, virtual, and occupied? Who feels very uncomfortable
With what?
with the words that you see here? So I skimmed through about 73% of the file, and there is a block that has keywords occupied, virtual, and alpha. So what are your expectations? What is your guess? What is shown here? Yes?
Occupied is occupied the states, and virtual is unoccupied.
Yes? And why there is alpha? Should there be omega or gamma?
Alpha is like first, so it's like kind of like the first. I don't know.
I'm just teasing.
Okay, does it really matter?
No, we'll go with more details over it, but right now, if we are dealing with singlets, there is only alpha. But if you will deal with higher multiplicity, like doublet, if there is electrons with spin up and spin down, there will be different sets of orbitals for alpha and beta.
So that is to deal with the multiplicity in that
Yep,
column.
yep.
Okay.
So, let me attract your attention to this table, and please try to bring it up at your computers. Please try to navigate to this spot in your output file. Since you all have the normal termination, you should be fine to see it. Let me walk around and see that everyone is at this table.
So when physics,
I mean, I was interested in it ever since I was a kid. I got this book on black holes.
If you
And
hit
it really interested
space,
me, and I've been interested in
scroll
physics ever since.
Neil deGrasse Tyson, I know he's astrophysics, but he is so much.
I don't know. I haven't read too much up on it.
okay.
What about you? How did you become interested in all of it?
So let's look on this table and share observations. if you look on these numbers in the rows and columns, what do you see?
Big -20.
Huh?
The big, the -20s. That's what I see.
But what is the trend? How they go from one to another?
Alone.
Huh?
They're getting bigger.
They're getting bigger all the time, right? So it's like monotonous function. Okay.
Oh, I see.
And there is about half of the table with oak and half of the table with virch, right?
Yep.
And here the line is incomplete. Right?
Is this home?
Yes. So let me bring up the help by David that he was drawing here. Like if we bring together several atoms and form molecule, then the standard spectrum of hydrogen atom changes in much more complicated spectrum of energy levels for a molecule, right? And some of the molecular orbitals are occupied with electrons, some are empty. Okay? So those are these numbers. So when we bring together several atoms, they start sharing electrons, it forms molecular orbitals, and electrons distribute over orbitals. Some of them are occupied, so many. And if you count total number of electrons in this 4 oxygens, 4 hydrogens, and 1 titanium, you'll get like 1, 2, 3, 4, about like what is shown here. Sometimes the lower shells, core electrons, are excluded from explicit consideration. Typically, it's amount of electrons on the outer shell. And for chemical and optical properties and electronic properties of material, most important thing happens at the edge between occupied and unoccupied. So the number here minus 0.5 and number here minus 0 are the numbers that determine properties of this molecule. Okay? So what is the meaning of the energy difference between these orbitals, occupied and unoccupied? Which physical property does it correspond to?
Would it be repulsive?
Repulsive, one thing. What else? Okay. Anything else?
No, but I don't see.
Conduction, yes. So if the occupied and unoccupied orbitals have the same energy, right? The material will be metal, conductor. If the energy offset between them is large, it will be dielectric, and in between it will be semiconductor. Excellent. What else?
Band gap.
But band gap, yes, energy difference between home and warm. But what does it correspond to? Like, how does it relate to visual appearance of a molecule?
The distribution of the molecular orbitals.
Huh?
The distribution of the molecular orbitals.
No. There is something. Distribution is cool, but there is something. Huh?
Refractive index.
Refractive index, yes, and very close to it.
Gloss.
Huh?
Loss? No.
Or are you saying like you're asking what does these numbers do with
Visual appearance.
I would think it'd be more reflective or glossy in a way.
Okay, so material visually can be reflective, glossy, and like what's the difference between your cell phone and keyboard? Or between your head and your phone?
Material.
Visually. At a
Color.
king.
Color.
Yes.
Well, it's accepting, so it'd be taking in different wavelengths. right?
So, yes, the energy difference between these two the difference between these two numbers determine the color of a material.
Oh.
The difference between the two.
Yes,
numbers.
yes.
Wait, which two numbers again?
So you look for the last one in the segment for occupied, which will be minus 0.5, and the lowest, the first one in the block for the unoccupied, virtual. But what is your opinion about the units in this table?
Now this is all in the ground state, right?
Yes, but ground state is very powerful. If you're not picky about like fractions of a percent, you do not need.
Okay.
Nathan may kill me for these words, but
So you are telling the electronic transition is happening from one state to another state, and it releases some kind of H new.
exactly, yes. But to be able, so by now you already are very powerful. You can stop attending the course and start writing papers, right? You just draw a molecule, run single point calculation, and tell convert this energy difference into like wavelengths and predict colors.
So this would be the minor contribution to the color, where the major contribution would be those transitions.
Homo-lumen transition is major contribution to the color.
Okay.
So what are the units here? Huh? No, unfortunately no. We need to do a little. What were the units for total energy?
Electron volts.
Huh.
Joule.
AU. And what is a conversion factor between AU and electron volts?
1 equals negative 27.
Right. So what is bigger, AU or electron volt? AU is 27 times bigger, right? So we need to multiply this energy difference by 27, and then you'll get the band gap in electron volts. So 0.0 times 27 is 0, 0.5 times 27 is like 13, right? So,
It's small then.
no, 13 electron volts.
13. Oh, that's yeah.
What is the electron volt number for, let's say, green color? Yeah. Or like, if you don't remember, in electron volts, you can tell what is the green color in nanometers.
It's gonna be 300 or 400, something like that. No.
300 will be blue.
It'll be, okay, so it's the other way. It'd be 5,
Closer.
5, 6.
5, 6.
Okay.
And the conversion from electron volts to nanometers.
It ends up being like 95 nanometers.
Huh? What?
The wavelength ends up being like 95 nanometers.
And 95 nanometers, which color is it?
It's ultraviolet.
Yes, ultraviolet. So ultraviolet, it means it is transparent, or it's like bluish, right? So first of all, Hartree-Fock method is not reliable for realistic observables. It overestimates numbers. But qualitatively, even if you do it with more reliable methods, it still will be in the ultraviolet. So this molecule doesn't absorb, doesn't emit light for human eye, and it will appear either as transparent glass, or if it is not homogeneous crystal, it will appear like white powder. So if you, just a second, if you look on the line for titanium hydroxide, for Wikipedia, you'll see like white powder, right? He was first, and
Yeah, but we were told TiO2, I know it's a different molecule, but yeah, it would be like a white powder, and then you're saying it's bluish because it's UV, so I'm kind of curious, kind of the difference there. Because you said it was like blue and UV, but then white.
so white, it means it equally reflects all colors, right? If it would be absorbing some portion of the spectrum you would see a color.
Yep.
So it's not color sensitive from human point of view.
Okay.
Okay.
I got lost how we decided that it would be in the electroviolet range.
Okay. If David will forgive me, I will erase his nice colors, nice drawings, and draw something else here. You have a right to say no. And what are the colors of the rainbow? Like red, orange, yellow,
Roy G. Biv.
green, blue, violet. So, and we do not need to exactly remember, but it's like green is about 600. Professional spectroscopists may correct me, right? Now, so what is the conversion from wavelengths to electron volts, to energy?
Electron volts to energy.
Mm-hmm.
Let's see by now.
Right.
We are assuming the larger, just question.
Yes.
The larger the wavelength, the lower the energy.
Exactly, yes,
Yep.
yes.
High intensity.
So if the wavelength is, let me make it simpler, if it is 621, what will be the energy? 2 electron volts, right? Okay, so anything with wavelengths larger than 800 and smaller than 300 will be invisible for human eye, or it will like appear either white or black or transparent. So 300 will be around 4 electron volts, and 800 will be around 1.5 electron volts, right? So we need to check that HOMO-LUMO transition, the energy between the orbitals shown here, falls within this interval if you want to have a colored material, right? Now there is another conversion factor. So the first we compute energy difference of lowest unoccupied molecular orbital minus highest occupied molecular orbital, right? So those are numbers here. So this will be HOMO, this will be LUMO. So LUMO will be minus 0.00971. We do not need so many digits. Minus 0.50599. I apologize for my calligraphy. What will be the answer? I don't want to practice it, but I'm just lazy to subtract numbers. Oh, thank you. But the BC command is not British Columbia, it is like board calculator. So if you type BC, and then you can like 0.50599 minus 0.00971. Okay? So you get the answer. The calculator is included for free in any Linux distribution. Yes?
Yeah, did you do the work, or who found that those two numbers would be actually what determines the way, or excuse me, what we see colored?
Right now,
Like, I
okay.
don't know if there's like someone who did this, said, oh, I noticed a correlation between those two numbers, or is it kind of figured out years ago, even before this?
Okay, right now we are considering practical skills and general trends. We are not going through like proofs.
Yeah, I was just curious if it was like not that long ago this was found, or if it was like 20 years ago.
Maybe simultaneously with Bohr's model. It's the reason for the discovery of quantum mechanics was inability of humans to explain spectrum. Any spectrum, generally and specifically the simplest, the spectrum of hydrogen atom. Because before discovery of quantum mechanics, everyone was believing classical, right? And classically, so there are several people from physics, they can tell the story better. So there was a planetary model of atoms, thinking that negative electrons and positive ions like revolve around each other, and if it slows down, like a satellite that burns in the atmosphere, it's continuously losing velocity and emits at any frequency, at any wavelength, right? Which is wrong, which is not what we see on experiment. And on experiment, atomic spectra are very discrete lines. It just emits or absorbs only certain frequencies. And in order to explain this fact, one needs to design so-called quantum mechanics, which tells that electrons can exist only in specific quantum states, orbitals.
Okay.
For atoms, solutions are known, both energies and shapes of orbitals. For molecules, it is not a good task for theorists to find them. It is much easier to run computation.
Yeah.
And what this table shows is energy, allowed energy at which electrons in a given molecule are allowed to exist. And transitions between occupied and unoccupied orbitals, meaning that electron sits on one orbital, jumps to another one, it means absorption or emission of light. So it's like basic concept that was developing simultaneously with births of quantum theory. Does it answer your question?
Yeah.
So,
Yep.
what happens to the black material which will absorb all the light, nothing will be able to? So, what electronic transition happens to a black material?
If it has dense spectrum, if there are a large number of states with very small energy offsets, it will appear black.
That means no electronic transitions are happening.
Well, both white and black means that it is either there are too many quanta at each frequency, or there are no quanta coming at all. Right? So we see color only when there is a disproportion, when there is amount of like red photons is more than proportion of blue photons falling into the light. If they will be coming into approximately equal proportions, we will see like black or white. So, what did we get here? 0.49628 atomic units. And this number, so what I'm going to do, and please follow, and I think we will finish soon, but I'll try to add exercise like this into homework because it is, and later on we will need to do it again. So the goal is to convert this number into units, either electron volts or nanometers, to say which color it will be, or if it will be away from the optical region. So in order to do so, we need to multiply this number by 27.1. So here in this board calculator, 27.1. So you see it gives the answer that lowest energy transition for this material, according to the Hartree-Fock methodology, will be 13 electron volts. And 13 electron volts definitely falls to the UV part of spectrum, right? So by looking onto this table, you can tell, like, we predict color of this material. Make sense? Good. So please develop questions, have some fun with equipment, but I think it's enough for today, right? Okay, formal part of the meeting is done.
Can we log on? You know, like,
When you are leaving, log off, type exit. But if you need to, if you want to play more, I'll sit a few minutes.
two questions.
Please.
So one was, I logged in using my personal computer a while back to make a slide. Well, I didn't exit out of there, but do I have to go back and actually press log out, be logged out, and then see?
Do it before you close it. After you close it, it terminates anyway.
It does terminate it. Yeah, okay. And the other question is, you know, we have a CCAS account with Dr. Reslo. I mean, I guess that doesn't matter.
It will be useless for the class. And you ask him to track everyone to open account if you didn't do it before.
Okay. So like if we went through what Thunder, that's better.
Thunder,
Yeah,
yes,
yeah.
everyone should have an account.
Yeah.